We're on air. So good morning, good afternoon, good evening. As I say, good part of the day, everyone. Welcome to the largest, fastest growing, and the most active large-scale Scrum community. Started here in New York City, has gone viral, global. Today, we have a very special guest. And before I give you his name, I'll tell you, I've been a pretty close follower of his work throughout my career. Also, some of my most most memorable clients have used his materials and his work in internal training. So it's actually it's a sign of something very significant. So it's Gojko Adzic, and if I mispronounce it, you will slap me for it. And he is one of the most reputable, most known people in the Agile world, in the Agile space. He's the author of Spec by Example. He's the winner of multiple awards in the UK, globally. He has been focusing on testing and testing automation and various Agile engineering practices. He also presented at the large-scale Scrum conference in Berlin a few weeks ago, which was another very impressive event. It was a keynote presentation, one of the keynote presentations. So, Gojko, I really appreciate you making this time and coming out and speaking to our global community. So people are actually privileged, even those people that were not able to make it to Berlin. They're here now, and this will be also recorded. So I would like to pass the baton over to you, the torch.
Thank you very much.
Torch. Could you please take it away and share with us your expertise?
Yeah, let's try that. Thank you.
Thank you very much.
Thank you very much for inviting me, and thanks everybody for joining. The topic of kind of the talk for today is kind of a quick recap of what my colleague Sigi and I talked about at the last conf. Jean suggested we do that again here. And it's really about figuring out how do we stop the insanity around how companies try to measure quality. Jean said that kind of I've been focusing on test automation, which is not necessarily entirely true. I'm a developer by trade. I started building software as a kid on a Commodore 64, and kind of pretty much I never wanted to do anything else in my life. And then a hobby turned into a profession. But I kind of had a luck of, when I started out working kind of in a small team, and I was in charge of converting a fixed amount of money that the clients were paying us into a variable amount of money. That's how much I was paying other people. And I realized very quickly that kind of my mission needs to be that when we kick something out, it needs to be kind of perfect or as close as perfect as possible so that it doesn't come back. And I've been since then really obsessed about creating high quality stuff. Through my work, I've kind of always focused on figuring out how do we achieve whatever kind of quality is for software. And last couple of years, I've been building my own products. Our Narakit is one of them. I built another product called MindMap. And I've kind of, again, in a position where if people complain, if there's a problem with the software, then it's kind of my personal problem. But both of these products are built by very small teams, and they both have millions of customers. So the stuff needs to work. And this has got me kind of thinking quite a lot about what we do as an industry and what can we do to tackle quality. And for lots of organizations, quality is this kind of woolly concept or kind of abstract concept where it's very difficult to pin it. It's very difficult to figure out what to measure and when. And my kind of thesis for today is that people spend a stupid amount of time measuring shit that makes no sense. And looking at kind of why we measure things and how we measure things can help us save a significant amount of time and have happier customers, build better products that are more successful. So one of the books that kind of really influenced a lot of my thinking about this is Doug Hubbard's book, How to Measure Anything. If you have not read that book, stop whatever you're reading, read that book. It's brilliant. It's not a software book at all. It's a book about business metrics. And there is some kind of mention of IT there, especially in what he calls the IT measurement inversion, where he says that people in IT are particularly bad at kind of measuring things that matter. And he has this kind of equation where he says that in IT people, the proportion how much people measure a variable is inversely kind of related to the value it provides. And he says that kind of in IT people often measure things that are easy to measure, not things that are important, because there's almost no model of value for any of these things. So although he's talking about business metrics, I think what he's talking about is perfectly applicable to what we talk about with software quality. Because if you look at what people measure, we measure things like bugs, we measure things like code complexity, we measure things like technical kind of complexity and things like that. And all these things are kind of easy to measure in a sense. They're not that particularly valuable. The reason why they're not valuable to measure is that they're mostly diagnostic metrics, not kind of performance metrics. So in the whole kind of business metrics community, they mention two types of metrics that you can measure. One is a performance metric where you're actually measuring the thing that is a leading indicator of value, and the diagnostic metric is measuring for the presence of a common problem or for the absence of a common problem. So diagnostic metrics tend to be very cheap and easy to measure. That's why they're used. And they tend to measure a specific problem that's common. For example, a high temperature is a sign that something's wrong with my health. If I have like, I don't know Fahrenheit, you guys are in Fahrenheit, but whatever the kind of high temperature correlated to fever is in Fahrenheit, if I get that, that means something's wrong with me. But if I have a normal temperature, it doesn't tell anything about my health. There could be a million other things wrong with me, but I just don't have a high temperature. So diagnostic metrics are like that. They're kind of common ways of cheaply measuring common problems. But the way we kind of look at software is most of what we do are kind of diagnostic metrics. And they're trying to measure some common problems, but they're not really proving that we are delivering anything of quality. So imagine yourself in a restaurant and you're sitting down and a waiter comes and you ask him to kind of describe a specific meal. You know, there's 3 meals, you can't choose one of them, and you say, well, you know, tell me something about this one. And the waiter basically says, well, that one mostly has no poison. That's what we're measuring with software. When I do a software testing cycle and I say, oh, we found only one bug, kind of, oh, we didn't find any bugs. That's exactly the same thing. It's kind of, this meal has no poison. Well, I mean, is that really the best we can do? So one of the first things that's kind of really important when we're looking at figuring out what to do with quality is to stop obsessing about these diagnostic metrics. Diagnostic metrics are kind of a very quick way of telling us that we are not facing something kind of really, really problematic, but they're not the end game. And in that sense, like if you imagine a car, kilometers per hour or miles per hour, and code coverage is also horrible as a metric. Code coverage is a total diagnostic metric. It provides zero value to anybody. Please don't throw shit like that. So, like again, very low code coverage can tell you that you have no tests. It's a diagnostic metric. Very high code coverage doesn't tell you anything. A very high number of bugs tells you have kind of a problem. Very low number of bugs doesn't tell you anything. The software might not be tested. So, and again, optimizing a diagnostic metric is dangerous. And I love that somebody mentioned code coverage, because in my previous life, I was a consultant. I used to work a lot with banks. Very commonly, there would be a target on code coverage. And you achieve a target on code coverage by creating stupid tests that don't do anything. Brilliant. We've kind of just misled people into thinking that we have quality and we don't. So code coverage, bugs, and things like that, they're all diagnostic metrics. Optimizing diagnostic metrics is dangerous because we waste a lot of time and we're kind of just playing with the incentives. So I did this kind of talk at a big bank a couple of years ago, and they were talking about how their mission for quality over the next kind of 2 years is to create like a zero bugs policy. And I was doing a talk, somebody from the audience was asking, I said, well, that's kind of the stupidest possible thing you can do, because you can create like a zero bugs policy for a release by never releasing anything. You immediately achieve that. So the goal of that is not to kind of never release anything. We need to deliver value, not kind of not release bugs. And so the first rule really that's important to start thinking about when we look at making quality more tangible is to differentiate between diagnostic metrics and value metrics or performance metrics, and then to stop thinking that we can prove the presence of quality by measuring the absence of something else, because we're just measuring the absence of something else. If I measure code coverage, I'm measuring whether kind of we don't have enough tests in a certain area. I'm not proving that the tests are good. I'm not proving that there's any quality there. Bugs are again similar, and famously, you know, there's software where you can create zero bugs, but it delivers kind of almost no value at all. Or kind of, does that even make sense to release? I mean, on the other hand, if we have bugs, but the software is making a lot of money, users are happy, maybe those bugs are not that important. Who knows? I mean, we need to figure out better ways of measuring things. And again, diagnostic metrics have their place. They're cheap and easy to measure, and they're a very quick way of detecting some types of problems. But they're usually pointing us to something else that we need to fix. So one of the things that then kind of we need to start thinking about is, if we don't just think about measuring diagnostic metrics, but start looking at measuring performance metrics, like what is that performance? How do we define it? And this is where lots of people, especially kind of, this is a large scale meetup, so you're probably working for large organizations. The kind of thing that I've seen over and over and over and over again is people try to nail it down to a single number. And then it just doesn't make any sense. It's too abstract, or you go and measure kind of, oh, we're measuring profitability of the bank. Well, brilliant. I mean, the software I'm working on is a tiny piece of a tiny piece of a tiny piece of a tiny piece of a tiny piece. Impact of that on profitability is ridiculously low, unless you're working on something totally kind of critical that's actually kind of money making. And even if you're doing that, does that actually measure the quality of your software, or does it measure the quality of people's trading strategies and a bunch of other things? So we need to start looking at, well, what do we measure and how do we measure it? So for example, for MindMap, that's a collaboration tool, we started looking at how frequently are people using our software, and are people using the software in the way that they were supposed to use it? And we started measuring that. And we were starting to kind of figure out whether we can do something to increase how frequently people use it, or how long they stay in using the software, how much value they derive from it. And then we start looking at lots of different ways of kind of accessing this and estimating it. And Doug Hubbard says in his book that once you figure out the value of a piece of information, then you figure out what's your budget for measuring that. from one perspective, the value of a piece of information, like are people using our software enough and things like that, is, well, is this a direction we want to invest the next 6 months of our lives developing it, or next 6 months of salaries and things like that? And then there probably is some budget for figuring out how do we measure that, because we can say, well, this information has a certain amount of value, and then we can think about, well, do we invest more in the testing framework? Do we invest more in this or that? On the other hand, we can look at investigating quality as de-risking certain problematic things from happening. That's also a very common way of looking at this. Like, if we deliver software that's broken, it will interrupt people's workflow. It will prevent traders from doing trading. It will prevent accountants from kind of compiling the accounts or something like that. And these things have risk, and we can start looking at, well, how much risk are we preventing with kind of delivering good software like that? And is our kind of measurement of quality good enough to prevent that kind of risk? So kind of the next important kind of thing to think about when we're looking at this is to avoid this misguided attempt to assign it all to a single number, because assigning it all to a single number is probably going to make it too abstract. And instead of thinking about a single quality, we can start thinking about, well, what are the qualities of what we need to do? Because the software you do, the software I do, has lots of different stakeholders. It has users, it has customers, it has people who are financing it. It has different categories of users, and there's different qualities that this thing needs to deliver to different people. Microsoft is really, really good at figuring this thing out, because if you look at something like SharePoint, it's ironic how difficult it is to share things in SharePoint, but when you hire or fire somebody in an organization, it's trivially easy to add them to SharePoint or to remove them from SharePoint. So in this case, they've kind of figured out a really good distinction between somebody who's paying for the software and kind of the value, qualities it provides to them, and somebody who's kind of using the software and the qualities it provides to them, and kind of balancing that all out. And kind of thinking about these qualities becomes really, really interesting, because they might surprise you occasionally. So, for example, if you look at accounting software is spreadsheets. So the big thing that the accounting software needs to do, it needs to be accurate. It needs to be trustworthy. But does an accounting system need to be beautiful? If you think about it, probably not. But then, kind of Xero comes in. Xero is a New Zealand software company. They kind of shot in popularity like a rocket 10 years ago. They're one of the kind of most popular accounting systems, at least in the UK. And their tagline when they started was beautiful accounting software. And kind of, so they got, they understood a piece of quality that nobody else understood. And they were able to take a lot of customers from their competitors by figuring this thing out. So we need to figure out kind of what are these qualities that we provide? What are the aspects that we can maybe try to measure as more direct, in a sense of kind of where the software needs to be. And then again, we can start thinking about, well, how much of each of these things does it need to be? Xero doesn't need to be the most beautiful software system ever. It doesn't need to be beautiful as software for fashion or some kind of other audience. It needs to have nice, clean, vibrant colors and to have kind of nice blue buttons instead of horrible gray buttons that Sage had and Intuit has and things like that. So kind of figuring this thing out is interesting, because there's not enough time and there's not enough money to deliver perfect software. There's never going to be enough time and money to do everything. And generally kind of time to market is critical almost everywhere. So figuring out the right trade-off of these things, figuring out, well, you know, do I need to make it more beautiful? Is it trustworthy enough? Or do I, you know, is it performant enough? What does enough mean? Becomes really, really interesting. So a couple of years ago, I had this consulting gig working for a company that paid the third-party software organization to build some affiliate marketing software. Affiliate marketing is basically you as an organization want to allow others to show ads for your product, and then if they bring you customers, you give them a percentage. There's lots of kind of software like this. These people wanted to have their own platform to control it. They paid the third party to do it. The third party did it. Everybody was happy. And then the next phase of development came. The client wanted a tiny change to the reports. The software organization quoted them twice the price of the original development. And then they started arguing because they started talking about who's scamming who, whether the software people are now rent seeking, and whether they kind of now they got a client, they're trying to kind of extract and scam them. And the client was a friend of mine, so kind of they hired me to actually figure out what's going on, because the software organization was telling them that although this looks like a teeny tiny change in the requirements, it's actually a total rewrite. And what they wanted to do is they wanted to have real-time reports. They had reports that were running at a batch once a month. They wanted to move them to real time. And for a client, this was like, okay, you know, who knows, a couple of days of work. For the software organization, this was throw everything in the bin and start over. This was before the cloud. This was before kind of you could get data grids and databases that are globally synchronized and things like that. And basically, the software people said, well, you know, nobody told us about real-time reporting requirements. It's all based as a batch process in order to do real-time and collect data all over the world. We need to build kind of effectively a data grid. The data grid didn't exist as a concept yet, but they had to build that. They had to kind of ship data on the queues, synchronize it, aggregate it across different locations and things like that. And this was an architecturally totally different system. So I went back to the client and I said, look, you know, the way this is kind of understood, the way you kind of positioned it, it is a total rewrite. There's no kind of beating around the bush for that, but maybe it doesn't need to be. Maybe kind of this real time that is fast as a property, maybe it doesn't need to be real time. Maybe it needs to be kind of, you know, somewhere in between, and then it's not a total rewrite. Can we talk to the people that asked about this? So then we started talking to the reporting managers, the affiliate reporting managers, about why they need real-time reports. And they said, well, all our competitors, they sum up kind of the profit and ads and money making weekly. They send it to their kind of affiliates weekly. Affiliates know which ads are doing well, which are not doing well, and then they can change things around. They can make more money. When the affiliates are better at marketing, we make more money. So, you know, we want to go real time so that people can continuously monitor this stuff. And we're at once a month now. Kind of your competitors are doing once a week. We need to be much better than them. And I said, okay, but so they're doing once a week. How about if in the first, you know, instead of once a month, we do once a week as well? I mean, that's better than before. He said, no, that's not good enough. We need to be better than. He says, well, you know, then maybe, I don't know, if we do this kind of every day. And the marketing manager we were speaking said, yes, that's exactly what I'm asking about, real time. And I've realized that kind of what this person says when he says real time and what developers understand when they hear real time are two totally different things. Because kind of with these reports, people need to create visual assets. They need to create web pages. They need to kind of do lots of different things. Getting a report every microsecond is pointless. Things don't change that much. They can't act on it anyway. Getting a report maybe a couple of times per day is brilliant, but once per day is more than enough, or at least was more than enough back then. So kind of instead of a total rewrite, by figuring out the right balance of these things, we were able to just reconfigure a batch job. They had to optimize the database a bit because I think the batch job was running for longer than a day. But when they got it running within kind of 20 hours, that was it. So kind of then we have another problem, really, because with lots of different stakeholders, people want different things. Somebody needs to come and say, look, it's not going to be real time because once a day is enough for you. Or it's not going to be real time because doing real time is an infinite amount of time and money. We don't have an infinite amount of time and money. It's going to be once per hour or something like that. And we need to invest more in this other thing. We need to kind of balance out these other attributes. So first we need to identify these attributes. And then when we identify these attributes, we need to figure out what's the right trade-off there. And the danger that I see, especially in large organizations doing these things, is that testers and developers and technical people start making their own minds about what's a good trade-off and where. And really, a trade-off, in this case, trade-offs between these things are a product decision. Trade-offs between these things are a critical investment decision, because somebody needs to say, well, we can do this and it can give you the trades, the report in less than a minute, but it's going to cost $5 million. Or we can make it so it gives you the trading report in less than an hour and it's going to cost $50,000. And then we can spend more time doing something else and things like that. So trade-offs between these things are really a product decision. They're not a testing decision, they're not a development decision, and they're a decision that is going to significantly influence the architecture, the testing, and everything else. And we need to get stakeholders engaged in this stuff. That's why when we get to the level of this, there should be like 5, 6, 7 of these things, not 500, but not one. So, there's a couple of tools that are useful to investigate for kind of engaging stakeholders in a decision like this. One tool I particularly like was invented by Ericsson, the telecoms company, or people at Ericsson, about 12, 13 years ago. And they were using it to figure out the right performance metrics for different things around quality. And they called it Cooper. I quite like Cooper because it's a very good way of aligning stakeholders very quickly. Now, there's two sides to Cooper. One is, if you go and read kind of the proper description, it's very academic. There's lots of different kind of things they do there. But my stakeholders, when I was working as a consultant, were kind of, they didn't have time to kind of figure that out. And there's a brilliant aspect to Cooper that I'm going to explain in 5 minutes that is kind of probably going to give you 80% of the value of the whole model. And it's not like Cooper as people at Ericsson describe it. It's an oversimplification, but it gives you almost everything you need. So Cooper is kind of quality performance metrics. And basically, it's a model that says that whenever we're designing a system, whenever we're developing something, there's like an S-curve of investment over benefit. So let's say that we are creating this affiliate marketing system, going back to that example, to get a report to run once a year. We need to build some infrastructure, we need to build some software. Once we make it to run once a year, then optimizing it to go once a month or once a day becomes relatively cheap. And at some point, we hit the limits of technology. We can no longer optimize that, and we need to rewrite it to use a data grid, to invent our own cloud, to do different things. So kind of there's an S-curve of cost versus benefit. And there are 3 points here that are important to use for discussion how far we want to go on this curve. The first point is something called utility. The utility point is the point below which your solution does not apply to the market. For example, with this affiliate marketing thing, because lots of competitors had like once a week, doing this thing less than once a month, just you can't compete. You need to be more than once a month, probably around once every 2 weeks or once a week. Then there's a differentiation point. The differentiation point is the point above which your product becomes so much better than the competitors that people will actively choose your product because of that. So in the case of this company, this was once a day. So if you do report once a day, all your competitors can do it once a week. You're so much better that you're gaining business because of that. And Kent McDonald has this rephrasing or kind of a parallel concept to this. He calls it the billboard test. He says, at what point do you start actively advertising this? At what point would you put that on a billboard? Like, our product does this. That's how good it needs to be. And then there's a saturation point. The saturation point is the point above which the market is not ready for further improvements now at this point. So, and you know, when I was consulting with these people, if you give your affiliates a report every 4 or 5 hours, or if you give them every 10 minutes, there is no big difference to their work. They need to prepare visual assets, they need to prepare ads, they need to create web pages. They're not ready to create this stuff on the fly. Now, with modern technology, you know, you have DALL-E and ChatGPT and stuff like that. You could probably just kind of hook it all to an API and do A/B testing automatically and things like that. So these numbers move, but at a given point in time, these things are some numbers for some of your attributes. And what's interesting about this is that these numbers are not dependent on the opinion of your stakeholders. These numbers are dependent on the market. They're dependent on what your competitors do, and they can serve as really good anchoring points for discussions with the stakeholders. We can say, look, we are building, I don't know, a mobile interface for a bank, and then we need to be able to schedule payments. Well, how quickly should a person be able to pay through the mobile app? What is the expectation of the market? Well, if you can't complete the payment in, say, 5 minutes, people will just drop it. They're not going to use your app, they're going to use something else. If you can complete the payment in 5 seconds, maybe we can talk about, well, we have the fastest app on the market. We, you know, our customers are brilliant, but if you get it down to like 1 second or half a second, nobody's going to notice a difference. And the change between half a second and 1 second might be millions in hardware and millions in development costs, but nobody's going to notice a difference at this point. So kind of figuring out these 3 things allows us to talk about, well, for each of these attributes, where are we now? Where do we want to be in phase 1, phase 2, phase 3? For certain things, like if you're doing banking software, how beautiful does it need to be? Well, you know, above the utility point, if it's so horrible that people can't use it, then nobody's going to use it. But does it need to be much better than the competition? How much better than the competition? Does it just need to be there? And you can use this kind of to have a good discussion with your stakeholders and anchor the discussion to figure out what the right trade-offs between these different things are. Another model that's kind of quite interesting that I like to use is based on the Maslow's pyramid of human needs. Maslow's pyramid of human needs basically is a psychological concept that says there's different things that change in importance as you satisfy them. So physiological needs like water, air, going to the toilet when your blood is full and things like that, they kind of take a precedence and priority over everything else. But once they're satisfied, once you have enough air, adding more air is not going to help improve the quality of your life. Then you start looking for other things. You start looking for physical security, you start looking for financial security and things like that. And then kind of it goes up and up and up. And basically the idea of the model is that if a thing on the lower level of the model is not satisfied, you compromise things on a higher level. But once the things on a lower level are satisfied, adding more of that does not help. So kind of looking at this for a client that was a big bank, we started looking at what do we measure, what attributes do we measure for our software, and we kind of use the pyramid as an inspiration. So we said at the bottom level, basically the software needs to be deployable. What that means is that within a certain time frame that for these people was 4 hours, we can move software from the kind of development environments and things like that onto the production. If we can't do that within 4 hours, pointless. We can't release it, we can't test it, we can't. needs to be functionally okay. So it needs to satisfy all these not have bugs. It needs to kind of do the things we want it to do and things like that. And then above that, we have like performant and secure. Once we have enough features, adding more features doesn't necessarily help improve the quality, but improving performance might be. If we don't have kind of a way for people to pay, it doesn't really matter how fast the system is. But if we have 3 ways for people to pay, adding a 4th way for people to pay doesn't matter as much as improving how well these things work. Then above that, we have, is the software usable? If we give it to users, can they potentially use it? Which we can test around how quickly does it take for somebody to click all the buttons? Do they find information where they need to find information, and things like that. Now, these 3 things are measuring kind of the output of our work. And very importantly, this thing is measuring the potential for people to do something. But then above that, we have, are people actually using it for what it needs to be used for? So we can measure the usability of a payment system by bringing in test users, by seeing if they can kind of quickly go through the flow and things like that. But then, are they actually making payments or not? If they're not actually making payments, what we're doing is not that useful. Maybe they're prevented from doing that because we're not offering something that we should be offering, or maybe we have a completely wrong product. I remember reading about PayPal. For some reason that's kind of beyond my understanding, and probably beyond the understanding of anybody outside the US, it seems to be incredibly difficult to move money from one bank to the other bank in the US. And kind of PayPal got started as something where people would be able to use mobile phones to send text messages or something like that to move money. And they built a testing website so that they avoid kind of the charges of sending text messages all the time. And then after a while, they looked at it and they said, well, nobody's using text messages, but people are using the website. So the text messages interface wasn't useful. It was usable, but it wasn't useful. Another really nice example of this is this kind of tool I'm working on at the moment that's called NarraKit. I built it so that it can help people create narrated videos quickly. In a sense, imagine throwing a PowerPoint in and putting in what you want the voiceover to be into presenter notes, and then just uploading the PowerPoint and getting a video. It uses AI text-to-speech to create the voiceover from your presenter notes. Now, when I kind of built this, the first version I've monitored for this, and people were using it. It was usable, it was useful, but then I figured a ton of people creating blank videos. That was really weird. I mean, because it seemed to be useful for something different than what I expected. Why would you create a blank video? And people are paying to create blank videos. So I started digging in deeper into this, and it turns out that I've made it usable much better than the competitors, but not the competitors I was thinking about. I made it for people to make videos, but I made it more usable than people doing text-to-speech interfaces. So what a lot of customers started doing is just using the kind of voiceover part to create a blank video with a voiceover, and then take the audio out of that blank video and use it somewhere else. And I realized, well, it's useful for a totally different purpose. It's not useful for the purpose I want it to be. It's useful for something else. And then I added an even better interface where people can just directly create text-to-speech. At the moment, there's about 180,000 conversions done per day. About 1,000 are videos. 179,000 per day are audio files. And the audio interface is making a lot more money than the video interface, although that was a totally different thing. So, like, measuring this is measuring the output of our work. This is starting to measure the outcome. Are people actually using it the way we expect? Are they using it for different things? And then at the end of the day, we have kind of a metric around, well, is this software successful? Is it creating the value for us that we expected to create? Is it bringing enough profitability? Is it bringing enough revenue? Is it bringing whatever value it needs to bring? If you're doing something on profit, Detmer in his book talks about how the value for non-commercial things is usually around reducing undesirable effects. So what are the undesirable effects that we want to reduce in the community, in kind of in a company, or, you know, is it making money by the end of the day? And kind of figuring these things out becomes really interesting, because the way you create this model will help you figure out whether you're going in the right direction, whether you're kind of doing the right things, but it will also help you avoid getting lost in ridiculous situations. So with each of these things, you know, once we satisfied one level, kind of the thing above becomes more important to look at. For example, a year ago, I had this really interesting situation where I was working a lot on optimizing search engine traffic and bringing new people into the system. So kind of the measurement for usefulness there is really, are people coming to the system from Google? Are they getting on with my product and things like that? And I had to improve lots of these things to do that. And I had to build kind of good interfaces. Google really appreciates if people come to your website and they stay on your website. So there's lots of kind of feature stuff that needs to be done for that. And then one day the traffic jumped about 5 times, and then it jumped 5 times the next day. So I had 25 times more traffic in 2 days, and then it jumped again. So looking at, like, have I done this that's kind of useful and things like that, was amazing. I had numbers I couldn't dream about. But then I started looking at, like, is it successful? Is it actually making money? Are the people coming there and paying for it? And it turns out no. And I started investigating this, and I figured out what was going on. Somebody found out how to abuse the free tier of my system, and they published a popular video on YouTube about this. Lots of people saw that and came and started abusing it. So actually, you know, it was too useful. It was the thing I added allowed people to abuse it. So I had to kind of get it under control and remove usefulness to make it more successful. And one of the things they were doing is they were using VPNs to kind of change lots of IP addresses very quickly, so that they could trick my free tier abuse detection. And one solution for that to make it useful was to build some features, build all this way up. And I built a thing where it said, well, was detecting if you're using a VPN. If you're using a VPN and you're a commercial user, it's perfectly fine. If you're using a VPN and you're a free user, it says, well, VPN is a commercial feature, pay to use it. And actually, my profitability increased quite a lot because of that. So, figuring out these attributes on all of these different levels becomes really interesting to create a model. So the next thing to think about, the next rule really is to create a model to combine all these different things and to shape the narrative of what you're going to be building and make sure that everybody agrees on it once we have this model. Especially for larger organizations, getting everybody to understand and agree your way of understanding value, your trade-offs, your model is important, because then we can delegate decision making. So you don't have to use this kind of pyramid model. There's other models you can use as well, but use a model, come up with a model. I'll show you an alternative model. It's coming from Google, and it's called the Attribute Component Capability Matrix. The Attribute Component Capability Matrix was invented by James Whitaker, who was a senior software quality leader there. And it's described really well in a book called How Google Tests Software. So basically, the idea of this model is that it's not possible to estimate the risk of individual software features, but it's possible to estimate the risk of some user capability being disrupted. So when you're looking at a payment system, well, the ability of people to monitor risk being disrupted creates a huge amount of regulatory risk, compliance risk, and things like that, the ability of people to pay. So it's kind of people's capabilities, what people can do with your software that is easier to kind of estimate the risk about. And still, but we're developing and testing features. So what they did is they created a model where you have these attributes, qualities, you have your system components, and then at the intersection of this stuff is the capability. So we have attributes, we have components, and we have capabilities that this component participates in that contributes to the system being fast or safe or something like that. And what we can do then is we can assign risk levels to these capabilities, and we can talk about, have we de-risked these things enough? Have we proven enough with our investigations to provide feedback to the stakeholders about how much quality we have or how much risk we carry? And again, the nice thing about this model is it allows you to create an agreement on how much risk you are allowed to carry. Because there will never be enough time to develop everything and test everything. We need to release. Time to market has value. So then we can talk about, we are okay to accept certain risks in production. We are not okay to accept certain risks in production. And instead of having to renegotiate that every week, this model helps you kind of create an understanding and a living model of that. And then kind of we can estimate the risk of these things, capabilities, and then you can have kind of an aggregate level of risk, creating, say, a depth and saying, this is how much risk our software carries at the moment. The more we test, the more we kind of improve quality, the more we want, it kind of raises above. And then when kind of it goes over a certain level, we are okay to release. We will accept that there potentially is a disruption to the capability of some back office admin doing something because we can fix it quickly, but we will not accept that there is a disruption to payment risk or something like that. And what's interesting about this is kind of it's really consistent with another really lovely book that I recommend people read. It's called 4 Disciplines of Execution. And 4 Disciplines of Execution talks about the big differences between companies that are really good at getting execution down to kind of create good value from their work, and companies that waste a lot of time. One of kind of the statements they have in the book that really stuck with me is that if you're not keeping score, you're not competing, you're just practicing. So kind of the question is, what do we keep score on? Can we kind of somehow keep the score on risk? Can we keep the score on value and track it and distribute it and help people make decisions on their own about this rather than having to renegotiate every week? Is this a critical bug or not a critical bug? Or do we have enough tests, or do we have enough code coverage and things like that? So kind of the last rule really that I'd like to propose people think about is that we can make the quality tangible by visualizing. We can use the ACC model, the pyramid, the kind of a ton of other things, but visualize the model and kind of act on the signals that it's giving you. If the risk is arising, then do something, redesign that piece of the system, improve it one way or another. We can then figure out what level of risk we can measure in production, what level of risk we need to measure every time, and things like that. And we can act on these signals. So kind of that's kind of what I wanted to talk about today. Let's leave some time for questions. And just as a kind of quick summary, to make quality tangible, we need to kind of figure out measuring presence, not absence. We need to figure out different types of qualities and different attributes, and looking at kind of trade-offs between these different things, engaging product management, engaging stakeholders in figuring out the trade-offs between these things, and then create a nice model out of it that we can then visualize, and we can then kind of collect these things as metrics, keep score, and then act on these things to actively improve our process and improve our products. That's pretty much it. Thank you very much. I hope I've challenged your thinking at least a bit and given you some new models and some new tools. We can talk about kind of questions now.
Gojko, first of all, thank you very much. Folks, we got about 6-7 minutes, give or take. Could you please just fire it well, unmute yourself, and ask the question and then go back and mute. Bart, well. Pretty shy.
No questions. Okay, then beer o'clock, I guess, Friday afternoon.
Folks, going once, going twice. Are there any questions?
I had a question.
Yes.
Yes, thank you. I'm just trying to start my video here. There we go. Regarding measuring the risk for a capability or feature, or whatever you want to call it, how do you do that? What I've done in the past is making a spider chart. So sort of understand reputational risk versus regulatory risk versus financial risk versus technical risk, that kind of stuff. And then sort of see what the feature with the largest area is, or what sort of techniques have you used?
So I think what you've mentioned there is really interesting, because you've identified, okay, there's a reputational risk, so your software needs to be reputable. There's a financial risk, it needs to be profitable, or kind of, these different things. And then we can look at, with an ACC matrix, what kind of different capabilities or attributes are capabilities are involved in that. For MindMap, for example, we used a very simple thing, because it's a smaller team. In how Google tests software, they talked about ACC having 20 different levels of risk. For us that was a bit too much, but we've looked at like the impact of something happening, and we looked at how quickly we can fix it if it happens there. And then we use these two numbers to kind of come up with 0, 1, or 2. And then we had a policy like, if it's 2, then pretty much anything that we touch, even if it's not related to this, we're going to test manually in this area. If it's 1 as a kind of risk level, then if we touch that specific area, we're going to test it. But if we don't touch that specific area, we're not. And if it's 0, then we'll just accept that kind of stuff in production, and we'll fix it when it happens. So I said at Google they had 20 different levels of things, and then you can create much richer policies around that. But I've used kind of the ACC matrix to break down that risk into different areas and to figure out the relationship between these things. And again, spider chart is a perfectly valid way of visualizing that. I've just not used it. But whatever model you create it in a way that's kind of visual, so people can touch it in a sense, or understand it and interact with that. And then you can delegate a lot of decision making by that.
Okay, thank you.
Thank you for the question, Craig. We'll take another one, maybe. Anyone else? Anyone? And go once? Going twice? Well, then that would be a wrapper. So Gojko, thank you very much.
Thank you for organizing this.
What shall we know? What should we know about your either upcoming series or courses, classes, webinars?
I'm not doing anything anymore. I'm busy working on my tools, so it's
Okay.
not.
Good.
There's nothing specific to know about.
All right. If there's anything you want me to circulate, you want us to know, just drop me a note privately, and I'll include it in
Will do. I don't think so. I hope just people enjoyed the kind of talk. Thank you very much for joining.
Thank you very much. It's great having you. Have a good night. Enjoy the night.
Thanks a lot.
Well, folks, thank you everyone for joining. Have a great the rest of the day, and have a good weekend. Cheers.